now I know now it'll be burned into my mind for the final that, hey, remember that screw up? Guess what?
But it won't always be good as a fit. Please.
That'll be
a lot of tests, and we're going to have more tests.
Yes, but it will specifically embed to my brain fitness, goodness of fit. Yeah, so I will specifically remember it because I've embarrassed myself with it.
Don't just assume it's good as a fit on the final because you're going to have more than one of these in a different test.
All three will be on, I'm sure.
Oh, and remember, we have like 20 tests.
What? We're gonna
we have goodness of fit. We have tests for a single population mean. We have tests for 2 means. We have tests for 2 means that are dependent. We have the test for 2 proportions. We have a lot of tests.
So many,
but we have a lot more tests. So we've already had a lot of tests.
Larry, will you please, like you did for this last exam, will you please go through for us and say, oh, numbers 1 through 7 will be like on the last. It was 1 through 7 was true or false.
Although it's going to be a little less specific because there's going to be some. It's going to be from one of these chapters kind of thing because the test is the same amount of time, but it covers twice the material.
Oh.
So I have to skip stuff.
Okay,
so the final's comprehensive.
Okay, so but you'll give us a super detailed one though still?
Yeah, but it won't have as many details. It can't.
Okay.
Because I want you to study both types, and I'm only giving you one kind of thing. Does that make sense?
Okay. Yes. Well, I appreciated the super detailed review.
Yeah.
Or not review.
If I give you one problem from every chapter, that's 13 problems right there. And notice there's 3 tests in this chapter.
Yeah. So how many questions do you anticipate?
I don't know. It's hard to know because there's parts of each problem. So there's one that's going to have a whole bunch of parts, and that'll be, so one of them is going to be real quick, like 5 seconds each part, but it'll be a different question each. So it doesn't equate well. The answer doesn't work. Okay. State the null and alternative hypotheses. So what I mentioned 2 days ago, there must be a specific word in the null and alternative hypotheses when you're doing goodness of fit. What word must be there?
Distribution.
Distribution. Okay. For goodness of fit, you must have the word distribution. So H naught. And now what we're looking at is we're looking at the distribution of car colors. So the distribution of car colors in Tahoe, because that's what we're looking at, is the same as in the US. I think I said US, didn't I? Yeah, US. Any questions on this? So notice that we're given the distribution in the US. We know that, okay? Because that I found on Google. Tahoe, we don't have a clue, so we do a survey. So it's one survey and one that you already know the population. And that's goodness of fit. You'll see today, if you don't know both of them, it's going to be something else. Okay, H1. The nice thing is, as I mentioned, since you're doing this on the computer, you can always copy and paste. Turn the not into a 1. And what do I need to add in? Just one little 3-letter word. How do I need to change to make H1 H1? Yeah, I need to put not right after the. So it's not the same as in the US. Any questions? Any questions on H naught or H1? Okay, so then we need to write down the table of observed and expected values. Okay, so notice that we got white, black, gray, and rest. So there are 4 different color types. Is that clear? Okay, we have 4 different color types, and we have observed and expected. So what I need to do is I need to pop in a table. And the nice thing is there's a pop-in table button in Canvas. So we have 4 different color types. We have observed and expected. And for headers, I like to add 1 more for each. So I'm just going to use O for observed, E for expected. And then our colors were, let's find them. White, black, gray, other. So white, black, gray, and other. Again, if you want to put the full word in, you can. Abbreviations are just fine, though. Okay, now the observed were just given. That should be really easy for everyone because the observed are 47, 43, 37, at least the first 3. 43, 47, 43, 37. How do I figure out other? How do I come up with how many others there are?
By adding up what you have and subtracting.
Yeah, so we're going to take 200 minus the sum of the rest. So 47 and 43 is 90. 90 and 37 is 127. That gives us 73 left. Any questions on that? Okay, now we got to figure out the expected. How do we figure out the expected number of white cars?
We take the 200 and we divide it by 4. No.
Not quite, because we're not expecting them to be uniform. We're expecting to be like the rest of the United States.
What we're really doing is we're taking the 200 and multiplying it by this percentage only in decimal form.
Yeah, so we're taking 26% of 200. So as Era says, we're multiplying. And I don't know if you know the trick. I tried to make this easy. So if you could use a calculator, but you don't need to. The way if you want to take 26% of 200, just multiplying 2 times 26. That's a deck of cards, 52. And similarly for the blacks, we want 19%. 19 times 2 is 38. And then for the grays, 18%. 18 times 2 is 36. And then for the others, we can subtract from 200, just like we did before. So first thing, we have 90, 126. So that is 74, if I did in my head right. Any questions at all? Any questions at all on the table? All right, so now let's write down the test statistic and the p-value. Let me write down these numbers so I don't lose them. 43, 37, 73, 52, 38, 36, and 74. Unfortunately, it's not a great way. You can copy and paste, but it doesn't work that great. So if I copy that, and then I go in, and just note, you do have to scroll down to find the test we're going to use. What test are we going to use? Should be obvious if you knew what the name of the test of the test it was. What number is it?
Number 20, goodness of fit.
Yep, goodness of fit, number 20. And then we got to type in the values. And let me show you, if you copy and paste, the problem is it doesn't put in commas. 47, 43, 37, and 73. And doubled those guys up. But it helps so you don't have to remember all the numbers you put in. I'm into copy and paste. It's a really effective way of not having to memorize stuff. And for the expected, again, it doesn't put the commas in. So 52, comma 38, comma 36, comma 74. Any questions on using this calculator so far? Okay, then hit calculator. There's our test statistic, and there's our p-value. The test statistic is 1.18, and the p-value is 0.76. So chi-squared is equal to 1.18. And the p-value was equal to 0.76, if I remember right. Any questions at all on finding the test statistic and the p-value? Okay, next. What we need to do is state the conclusion in the context of the study. So to state the conclusion, what we're going to do is we look at the p-value. Okay, notice, if I remember right, I don't think I gave you the level of significance. Why does it not matter what the level of significance is?
I thought that it didn't matter because this is at least what I did during my quiz. Since the range was 0.01, 0.05, and 0.10, I knew that that p-value was above all of those, so it didn't matter.
Yeah, it's above anything that you would ever imagine using. Okay, no one's okay with being wrong 76% of the time when they're publishing papers. Okay? It's not okay. Okay, so this is definitely bigger than any level of significance you'd ever imagine using. And in that case, what's the conclusion? Well, the first two words are, even the first three words, always the same.
There is
Statistically. Statistically. And then is it significant or insignificant?
insignificant.
Yeah, insignificant because our p-value is so big. Evidence to conclude that, and now we don't have to even do anything other than copy and paste and change the T to the not capital. That the distribution, lowercase the distribution of car colors in Tahoe is not the same as in the United States. Any questions on? Showing errors. I know Michael had to go back to work.
Real quick, you'll see that Braulio is here. Braulio is
yeah, Braulio, you want to introduce yourself?
tutor, so and he did a wonderful job. So please visit him.
Can you introduce yourself?
Hello, everyone. My name is Braulio. I'm a math tutor at the Cranium Cafe, offered by the library. I'm also a stats tutor, so I'm covering for Anna today. I can help you out just as well, I think.
Has Anna let you know how long it's going to be until she comes back? Huh?
It's only for today.
Just for today. She'll be back Tuesday. Okay.
She told me Tuesday, and she gave me, Tuesday to Thursday timeline.
Okay. Okay. And is she going to be around for any kind of tutoring hours like Monday or?
I'm not sure. I know she's scheduled on Sunday. I think she's going to be back by then.
Okay, she'll be back. Because she didn't tell me. I thought maybe you know, maybe you don't. I don't know.
No, she didn't. Again, she just covered Tuesday, Wednesday, Thursday. If she updates me with any more time that she needs covered, then I'm sure she'll let you know as well.
Okay, thanks. Thanks. Okay, so ready for number 2. So let's take a look at number 2. Is the Gaming Commission is investigating whether a casino is cheating at the craps table. Okay, by the way, you don't have to know anything about how to play craps. Okay, that's not necessary. Okay, they want to see if they're using weighted dice. They observed 1,200 die, and the table below shows the number of each landed value. 182, 241, 187, 204, 215, 171. Okay, what is the name of the test that you're going to use for this? I think I copied it over here. Good. What's the name of the test?
Goodness of fit, because that's
There's
what
a goodness fit, exactly. Okay, it's goodness of fit because we're given a distribution, and in one word, what distribution is it supposed to be? Have they not been cheating? In one word.
normal.
Definitely not normal, but good try.
Uniform, uniform.
Uniform. Okay, because we're talking about rolling a die, and the probability of a 1, 2, 3, 4, 5, and 6, those should all be. So when you're rolling a die, then it should be a uniform distribution, or they're cheating. Does that make sense? So in particular, we're looking at goodness fit test. And we're going to have our null and alternative hypotheses. It's not. So first thing, what word must be there? Any guess? What word must always be in H naught and H1 when you're talking about null and alternative hypotheses?
Distribution.
Distribution, okay? I keep saying it over and over again because I'm telling you, I grade tests and everyone forgets, and then I take off points. So I don't want to take off points. I want you to know. So the distribution of die rolls is uniform because that's what we decided. Any questions on that? Okay, now just like we always do for goodness fit, because copy and paste. Take the not, make it a 1. Take the is, make it isn't or is not. Any questions on H naught and H1? All right, so we've got that. Now we're going to write down the table of observed and expected values. And notice that we have a bunch of numbers here, which will help, by the way. So for our observed and expected, let's go ahead and do this. There. And insert a table. 7 by 3 this time. We're going to have a 1, a 2, a 3, 4, 5, and a 6. We're going to have the observed and we're going to have the expected. And the nice thing is the observed are just the numbers in the table. I don't know. Let's see if it'll let me do it. I'm going to try. Copy and paste. Nope, didn't. Good try though. All right, 182. 241. 187. 215. Oh, sorry, I missed one. 204 first. Then 215. And then 171. Because that's what we're observed. How do I come up with what was expected? We had 1,200 die rolls, by the way, total. I did that to save you some time. How do you come up with expected?
You take the total number, which was 1,200 in this case, and you divide it by the number of things you had, which is 6. So 6 into 1,200 is 200 each.
Good, and it's 200 for each of them. Any questions on that? Okay, I guess, oops. I was supposed to do that over here. Missed. There we go. That was part C. Okay, so the next part, write down the test statistic and p-value. So again, I don't want to retype all these numbers, and I think I can get away with it. We'll see. I'm going to copy that. I'm going to use goodness of fit again. Still goodness of fit. It's all we've got today. And there's the observed, but we need to put some commas in. And the expected. 2, 4, 5, one more. Okay, any questions on the observed and the expected? I calculate. Our chi-squared is 16.28 and our p-value is 0.006. So that was 16.8 was our chi-squared. And the p-value was equal to 0.006. Okay, again, I didn't give you a level of significance, but I don't need to on this one. How come?
Because the standard levels of significance or alpha can be assumed again. And
yeah, and 0.006 is less than any of them you'd ever use.
So yes. So even me, guys, and you'll hear my questions. Even me, I went, oh, hey, I got this. Assume.
Good. Okay, so when we have such a small p-value, what do we say?
We say, if the p is low, reject the hoe.
Okay, keep going, but the first few words.
There is.
There is. And then statistically.
Statistically significant evidence.
Okay, and then the easiest thing to do is copy and paste. Because you're always finding evidence for H1 or no evidence for H1. That the distribution of die rolls is not uniform. By the way, do you think I ever use this? In my personal life? Not exactly. It turns out craps is not something you can win. But I did exactly just about the same thing for cards, for blackjack. Is that in the old days, this was the old days when it was mafia driven, they used to bring in cheaters on me. And I do a chi-squared analysis to find out if they were cheating. If they were cheating, the first thing you do is you don't yell at them and say they're cheating, they're mafia. Never yell at the mafia. That's a really smart thing to understand. Instead, you just walk out of the casino.
They're all sensitive about it.
Yeah. Yeah, there's no strategy where you come in and craps, even in the old days.
Larry, I think the mob is still a little bit involved.
No, it's all corporate now.
All completely.
Yeah, it's all completely corporate.
Even
Everything's different.
A little
Yeah,
one's
it's not what it used to be.
Fremont Street.
Yeah, no, the mob's not involved in the casinos anymore. But they definitely started them. And when I was a kid, when I was 21 to 25, they were, or 23 or so, they were deeply involved. And I know for lots of reasons. My grandfather was one of the cheaters. Just to give he's dead now, so I could say it. but chi-squared analysis will decide whether someone's cheating, because you can look at it. In that case, I looked at a chi-squared analysis on the face card aces versus non-face card aces, and worked it out. Do it on my head. It's hard. And if they were cheating, then I just walked away. Okay, so I figured I'd throw this problem at you because I actually used it. You won't, because that was historical times. And craps, you'd never. If you ever think you're going to win consistently in craps, that means you own the casino, and then yes, you will win because you're the casino, not the player. Just let you know that. The automatic way of making money in the casino is work for them, and they will give you a paycheck at the end of the month. Okay, and I think they open today or something.
Yes, they open today. Are you going? No.
No, I don't go to the casino.
No, ever. But you work there sometimes, analyzing, right?
A long time ago. No.
No longer.
Not a long time. Yeah. Okay. So anyhow, figured I should mention that this is actually used, chi-squared analysis, and it was used by me. Haven't met anyone else that did it, but it worked. It was very effective. Okay, so now let's get to new material. And we just have a couple of you. And that happens. I don't know where everyone else is and why they're not coming. They're just watching it, and that's okay if that's what they want. A lot take quiz, by the way. You don't know that, but they're taking the quiz because I'm great in quizzes. They just don't. They just want to watch the webinar on YouTube instead of live, and that's their decision. But at least you two are here. My quorum is 1. If we don't have anyone here, I don't give a lecture, by the way. Okay, so what I want to do is I want to answer any project 2 questions. Michelle and Ares, if you have questions, this is your chance. Okay, this is your best chance for immediate answers. Right, I guess the only other chance would be Friday at 11:15 or so, and Monday at 11:15 also, because those are office hours. Any questions? Okay, hopefully you've made progress, lots of progress on the project. So I want to remind you a few things. Is that if you email me your draft, I will read it, and I'll give you suggestions so that you can do better. Very few people get A's on the project without sending it to me first. Okay, and it's not because I take off points if you don't send it to me. But if you don't send it to me and you make a mistake, then I let you know on your grade that you made a mistake. Whereas if you send it to me and you made a mistake, then I let you know, and then you fix the mistake, and then you turn in your final project, and there won't be a mistake anymore, so you don't lose points. Okay, so that's why I strongly recommend you send it to me. I only read 1 draft, though. I learned my lesson a long time ago. I'd have people send it, and they'd send it again, and they send it again. And we're talking about, 8 pages of reading 15 times. I can't do that.
Larry, originally I made plans to submit it twice because Anna told me that would be best. So
Anna needs to know better.
I need to let her know that it's only 1 submission.
Yeah, she forgot. She was my embedded tutor in the fall, so she just forgot. So she's heard my rules before. She just forgot.
She's super great. And guess what? If she says
great.
Twice after the first time you submitted it anyway, you probably wouldn't need to again because you're so excellent with your details of what to fix.
Oh, I'll give you lots of details.
Yeah, that's
I'll
great.
give you a lot, but I don't write it for you.
Of course not. But on the first project, that was incredibly helpful.
Yeah, I'll tell you what's wrong. I won't tell you how to write it right. I'll just tell you this needs to fix, this needs to fix, this needs to fix. Usually 10 or so. Usually I do a top 10. Sometimes it's somewhere between 8 and 15, typically. Okay, any questions at all? Okay, I do want to emphasize standard error is a big part of the project. It's also going to be the most challenging, so that has to be in it in a big way. And Braulio can help too, right, Braulio? Yeah. So Braulio can help. I don't know what your hours are over the next few days, but but I know you can help because you've done the stats thing too. Okay. Well, if you don't have any questions, then I'll move on to test for homogeneity. So I want to mention something because I can bring it in.
I do have
And
one
that question.
I do have one question.
Sure.
I noticed on the quiz today, in the questions, you asked, as always, the T and the p-value.
No, not T, not T.
That's what
chi-squared.
I'm going, because it says in the question, it says name the T and the p. So
No, it says the test statistic and the p-value.
yeah, well,
Test statistic is not T.
I made that the T. So I'm wondering, in other ones, it is a T and it matches up to a T. So in this one, when you say test statistic, you specifically, you don't just want T and P. P still works for the p-value, but specifically, you need to say, like in today's, the chi-square.
Yeah, but in general, it's called the test statistic, but it's chi-squared for this one. Let me show you something. There's a reason why I just jumped to this page. I got to go back one though. There we go. Just a second. Since it is here, I think it's 11.2. So this is the chi-squared test. And notice it's different. And in fact, I actually created an app. You can actually see the chi-squared. This is very different than what the T looks like. Remember, the T is symmetric. The T distribution is symmetric. The chi-squared is not a symmetric distribution. It's actually a skewed right distribution. And depending on the number of degrees of freedom, which you can change and look at, you get a slightly different distribution. So it's not the T distribution. T distribution looks kind of like a normal distribution, right? A little taller on the tails, but otherwise it looks normalish. This one doesn't look normal at all, does it?
No.
In fact, if you look at it, it never gets beyond 0. There's no negative values for chi-squared. And that has to do with the fact that in the math, there's a square. That's why we call it chi-squared. So it's definitely not the T distribution. Does that make sense?
Yes, I just wanted to that came to me at the end. I just wanted to clear that up because T is different than T for test. So I went, hey,
Right.
wait, it seems like, wait. So yeah, thanks for clearing that up.
Yeah, yeah. The letter T does not stand for test, by the way. That's not what it came from. It was a student's T distribution. And I'm not exactly sure. I think it had to do with the letter T, like the capital letter T, but I'm not even sure. Okay. But I know it was a hidden name because he didn't want to admit, he didn't want to make it public that it was his brewery. Because then other breweries would do it and then they would win on the business, and he wanted to win on the business. So, pretty cool stuff. Good history. So anyhow, now let's go ahead and talk about the test for homogeneity. So the test for homogeneity is different, and let me explain kind of how it's different. Let me remind you of the quiz of question 1. Okay, so question 1, we knew the percent of colors in the US. And then we wanted to see if the distribution of something we don't know is the same as what we do know. Okay. On the other hand, let's suppose instead of comparing Tahoe with the United States, maybe we want to compare, how about Tahoe and Reno? Do you know Reno's percents? The whole population of Reno? No, and you probably couldn't go online and find it. My guess is that information would not be available. So how would you do that? Yeah, you would do a sample. You would do a sample in Reno and you would do a sample in Tahoe. So, but you can't use goodness of fit because goodness of fit is when you're comparing a sample to a known population. But if you want to do, say, Tahoe versus Reno, you'd be comparing one sample to another sample. Do you see the difference? Any questions on the idea of that? So that's the test we're going to use for that is called the test for homogeneity. So let me write that out a bit. And it's often called the chi-squared test. We're in the chi-squared chapter, by the way. The chi-squared test for homogeneity is used to decide if there is a difference between two unknown distributions. And note that is different from the goodness of fit test, where the goodness of fit test is you're comparing an unknown to a known. That's the difference in the homogeneity and goodness of fit. Homogeneity is unknown to unknown. Any questions on that? So sometimes you might want to do, well, are men different than women in their, favorite color or something like that? There's all for qualitative data. Are Hispanics different than Caucasians? Okay, so you're going to look at one group versus another group, and you look at their qualitative answers and see if there's any difference between the two. Any questions? Any questions on the idea of the test for homogeneity? Okay, it turns out that they both use the chi-square distribution, goodness of fit and homogeneity. They use it in a very different way. I'm not going to do the mathematics because it's way too hard. Braulio, it's even too hard for you, just let you know that. the full mathematics, it's brutal. It's an infinite limit of integrals. We're not doing it. Okay. Yeah, goodness of fit means you know one distribution and you want to find out if some unknown distributions is what you knew for the other. Whereas homogeneity is there's two distributions, you know neither of them, and you want to find out if they're the same as each other. Does that make sense? Okay, and all of this in this chapter is for qualitative data. This is the qualitative data chapter. Okay, any questions on this? Okay. And as I mentioned, the math is brutal. We're not going to do it. All right, so let me give you an example where it's used often, that you've all seen this kind of survey before. And that is the following 2-question survey, I'll put a dash there, was given. Number 1 is, I support large gatherings to protest the Floyd killing. Strongly agree, agree, disagree, strongly disagree. And number 2 was, I support reopening the city, including allowing large gatherings. Strongly agree, agree, disagree, strongly disagree. This is a big deal right now. This is what everyone, everyone's a little concerned about the fact that we have these big protests. And the question is it safe? So I figured I'd throw one in. The reason I wasn't able to find something like this online, anyone know?
It's all just happening right now. So
yeah, it's too soon. So it's too current. I know this is going to happen, though. I know they're going to do a survey like this. So I did make up these numbers, by the way.
There are things in the media today already saying that the large gatherings and talking about, because a lot of the gatherers are younger, there may not be as big of a spike, but there will be some repercussions from.
Will be a spike, but the spike is going to be delayed.
Yes.
Because it takes a while to get it, and then you have to give it to someone.
Yes.
The young people are going to get it, not know they have it, and then they're going to go to their grandfather or their grandmother.
What I've seen just today is that they anticipate the results of this last 8 or 9 days of protest to show up in 5 weeks.
Right, but it's gonna be very hard to know if that was the reason.
Yes, of course, because they opened the doors a little bit more just at the same time. So it will be difficult to nail it down, but it will show.
But what you can do is you can do a survey like this. Okay, and who remembers, and this is kind of neat to you too, but I mentioned this when I talked about chapter 1. Don't you hate that? What do you call this kind of survey question? Strongly agree, disagree, strongly disagree. This was a chapter 1 discussion, and we're in chapter 11 already. And remember, discrete, not quite. Discrete is for quantitative, and it's definitely not quantitative. Does that make sense? There's a specific name for this. Okay, it's called a Likert scale, and in particular, it's a 4-point Likert scale. And that's the name of what you call strongly agree, disagree, strongly disagree. Whereas a 5-point Likert scale, what do you stick in? You remember? When you're doing surveys? Doesn't ring a bell. Yeah, that's how we stick in, but you just mean you don't remember. You stick in between agree and disagree, neither agree nor disagree. So you let the person not really have any opinion, basically. And that would be called a 5-point Likert scale. So a 5-point Likert scale allows someone to be neutral, whereas a 4-point Likert scale does not allow neutrality. You have to agree or disagree. Okay, so that's just a note. And it comes up in a big way in psychology, actually. It's a very common psychology kind of survey. Okay, so I want to let you know I made up these numbers. A survey wasn't really given, but I would not be surprised if they did a survey like this, because everyone's talking about this right now. Okay, so I made up these numbers, and the question is, I decided to abbreviate it so that I don't have to go back up and down and stuff. Just run the full hypothesis test. So all the typical questions you need to answer. So what's the first thing we have to do? What's the first thing I asked you on the quiz? Who remembers? Yeah, what test? What's the name of the test? So what is the name of the test? The hint is I just said it at the top of the page. Yeah, test for homogeneity. So first thing is the test. Use a test for homogeneity. Okay. Just a note, the book we're using, the OpenStax book, originally, they didn't cover the test for homogeneity. So actually, I emailed the author saying, this is like the most important chi-squared test there is in terms of any of the work I've ever done for consulting and stuff, and that we really should put this in because this is more important than the other two. Do you know what her answer was?
You're the king of statistics, so no problem.
No, it was, I agree with you. Can you please write it?
Same thing.
So this is the only few pages of the whole book I wrote. Okay, I did do all the programming for the apps, but that's not in the OpenStax book. That's in my version. But the new OpenStax, I'm a co-author for those few pages. Just let you know that. Okay, and it's used by over 1 million people. Okay, so In particular, we're doing a test for homogeneity. Again, it's used a lot. It's a very common test. Okay, now what's the next thing I always ask you to do? After you've strategized on the test to use, then
State your null hypothesis and
Yep.
state the hoe and the one.
Yep, so H naught. Okay, now this one's very similar to goodness of fit. Okay, but instead of the word distribution, here you have to put distributions because we're comparing two different ones. So the distributions of answers to the two questions differ. Okay. So I want to remind you, we're in chapter 11. In chapter 11, the null alternative hypotheses are always full sentences, words, no symbols. Whereas in 9 and 10, no words allowed. So don't forget. Sorry, distribution of answers, not differ, are the same. H1, I can copy and paste, change the not to a 1. And now the distribution of answers to questions differ for H1. So H naught is that the distributions are the same. H1 is the distributions are different. Any questions on this? What makes this hard is not that this is a really confusing, complicated sentence. Most people don't have problems with that. What makes it hard is that there's so many different kinds of H naughts and H1s that we've had now in class. We have some more coming up that you can kind of get lost on what's what and what test to use and all that. So that's what you want to practice. So you want to make sure that when you're practicing for the final, you don't just practice homogeneity a bunch of times. You want to go back and forth and get used to being able to identify and remember which wording it is for this particular test. So that's just a warning is, of course, we're doing homogeneity because that's where we are right now. But on the final, you never know what you're going to have to do. And I can't give you every kind of test because the exam would be too long. Any questions so far? Okay. What's usually the next thing I ask you to do?
The test and the p-value.
Test statistic and the p-value. And to do that, as you might guess, we very much need a calculator. Okay. And the computer calculator, again, I programmed everything we need in this class. I'm gonna, yeah, I think I can copy this one and paste it. We'll see. I'm trying to remember how this calculator worked. So this should be obvious. What number are we going to be doing?
Number 22, test for homogeneity.
Yeah. I tried to make it easy. If you know what test to use, then it should be obvious which one to use on the calculator. And if you have suggestions, if you don't like the way I worded something, I could change that. I wrote this, so I can change it. Okay. So we go to test for homogeneity. Yeah, this one copy and paste won't work. So because now we have an A, we have a B, and we put in the numbers. So now let's go ahead. Let me write it down. 56, 56, 72, 45, 51, 42, 54, 44, 60. And I type these in, 56, 72, 45, and 51. 42, 54, 44, and 60. Any questions on this? I want to make a comment. I only have up to, I think, 10 that you could put in. I won't give you a test with more than 10. This is wasting your time. But if for some reason, like, in your life, you needed more than 10, what do you think you'd have to do? Any thoughts? And I'm here, y'all jumping in. You'd have to use the spreadsheet program I wrote or another program. Okay, so this is purposely made for exams where no one's going to give lots and lots of numbers because it's a waste of time. But for real life stuff where you might have 100 different and 100 different types, then it could be more. And then the spreadsheet has a test for homogeneity, has goodness fit, and it also has independence. So, and then you can put as many as you want. It's a spreadsheet, so it goes on forever if you want, thousands.
As a just what if, say you only had 10 spots and there was no spreadsheet, what would happen if, like at the bottom here, the last two numbers you have on A is 45 and 51, and on B is 44 and 60? What if you were to add that up and put 96 in one and 104 in the other? So you compensated for the numbers, but you still didn't compensate for there was another entry. Would it work?
No, but it's a good try. You actually get the wrong answer.
Of course. Yeah. I try like nobody's business.
Yeah, you can't hurt to try, but yeah, you'll get a different. It's the mathematics will show it, but the math is too hard for me to explain.
It is important that you can't combo up, you can't shortcut things like this. It has to be separate entries. There's no way other than, and I'm not saying don't. I'm just curious. It just came to me. What if? So
yeah, you get a weaker test statistic. You get a higher probability of a type 2 error. And that's not what you want. And spreadsheets are out there. Like I created one. The only free one I know of is the one I created, though. But there's lots of ones that you can pay, But full spreadsheets are out there. And there's other programs where you can say add 10 more. But I decided this is just for testing. There's no reason to do that. No, it just makes it more complicated. So I tried to keep it simple. Okay, so anyway, that's it. Hopefully you agree it's simple to do that. And you hit calculate. Okay, and there we have it. Chi-squared is about 3.97. And the p-value is about 0.265. Good enough. That's the next thing. Chi-squared is equal to 3.97. And the p-value is 0.265. And the good news is we can state our conclusion, and I probably don't even have to even explain how to state your conclusion if you have been paying attention the last few weeks on how to state conclusions from hypothesis tests. So what are the first few words? You all better know this. Both of you. First three words are?
There is statistically.
Yep. There is statistically. Okay, so you just get the pattern down. It's the reason why, even though, sometimes like on the homework, you'll see 2 or 3 different ways of writing it. What I recommend is get used to one way so you don't have to learn a zillion different ways, and it's easier. Know how to read other ways, but if you just do one way, and that's why I always do one way, it makes life a little easier for you, because then it's just always the same start. And then it's either going to be significant or insignificant. And what is it in this case? Yeah, this is insignificant because the p-value is 0.265, which is bigger than any level of significance you'd ever use. So insignificant. Evidence to make a conclusion. There's a few, you could say, or to conclude, however you want to say that, about whether. And then I can just copy and paste H1. The distributions of answers to the two questions different. Does this mean they're the same? Are the distributions the same? Because we weren't able to say they're different? No, no, never, ever, ever, ever accept H1. Okay, you can't ever do that in statistics. Okay, you never say H1 is true. You can only say H1 is true, or we don't have enough evidence to know. Any questions at all on this example? Okay, what I want to do now, we only have a couple of you, so I am not going to send you in this separate room. But what I want you to do is I'm going to have you work on one, and I had it, and then I went over to a different section, but I can easily get it back. And I figured I have you work on one from the book, which I might have written like many years ago when I wrote this part of the book. Get there. Okay, so let's look at 11.5.2. And I'm just going to read it out. Do men and women select different breakfasts? The breakfast ordered by randomly selected men and women at a popular breakfast place is shown in the table. Conduct a test for homogeneity at a 5% level of significance. And we have men, women, they can order French toast, pancakes, waffles, or omelets, is what the menu looks like. So what I want you to do is I want you to work on this. And you can talk to each other. I'm going to stay quiet. But I want you to chat. So Michelle and Az, you get to chat. And let's see if you can come up with the full solution. So again, you have to do, and I've been doing this over and over again, all the different parts of the hypothesis test. So you can start with the test, name of the test. It's kind of given in the problem, but you should write that anyway to get used to it. One thing most people have trouble spelling it.
Okay, thanks.
So let's see if the two of you can work on it. And get while you do that.
All right. Michelle, you ready?
I'm definitely ready and listening and writing it down. Okay, so obviously the test is the homogeneity test. Our H not statement would be, I can't actually see the whole, oh, it's only the breakfast one, right? The part below that, the fisherman one, is a whole nother question. All right.
Here I've highlighted, do you see?
Do men and women select different breakfasts? The breakfast ordered by randomly selected men and women at a popular breakfast place shown in the table. Conduct a test for homogeneity at a 5% level of significance. So this is going to be, the null hypothesis is going to be,
The distributions of men and women eating breakfast or selecting breakfast is the same.
right. And then H1 is simply not the same.
Yeah.
You're close. A little better wording would be the distribution of breakfast orders.
So it'd be distributions, right?
Yeah, the distributions of breakfast orders is the same for men and women. So it's
Okay.
not the distribution of men and women, it's the distribution of breakfast orders. You see?
Right, right, right.
And as you guys are probably getting used to, a lot of words in this class.
Yeah.
Not like an algebra class.
I like these words much better than I like the symbols. I got this.
Keep going.
I'm just finishing writing yours and then I will.
Yeah,
right.
I'm writing too.
Oh, I didn't get the numbers.
Right. What I just did, there's a reason why I did that to you, is I wanted to get the link in case you didn't have it for the calculators in the chat box. And that makes finding the calculator a little faster. So I wasn't being mean. I was trying to get that link up there for you. It's the same link I always use, but you may not have it quickly as accessible.
All right. So the next part we do is the test stat and the p-value.
Right, so we go to the homogeneity calculator and we put 47, 35, 28, and 53. And then in row B, 65, 59, 55, 60. That gives us a chi-square. Let me write it down. A chi-square of 4.013 and a p-value of 0.260. And 5% level of significance. So the p-value is higher, definitely dramatically higher than 5% at 0.260. So
Larry, on my calculator, I don't have A and B. I just have like one long bar.
you just separate by commas then. But that's the wrong calculator.
Wait, you're on the, okay, so when you went to the calculator, did you go test for homogeneity?
Yes.
And so I'll follow along with you. And then if you scroll, you should see this.
Different format than yours for some
Okay,
reason.
let me see what happens if you make it really small. Might have to, okay. It might be, are you using a smartphone?
No, I'm using a computer.
Really? Because it might be that it's squished.
I'm not using your link. I'm actually using one of the calculators on the exam.
On the exam.
Sometimes to get to
okay.
the calculators.
So there may be an issue with the exam. So that's a good thing for me to know for the next exam, which I haven't written this yet. But it might be because there's not enough width.
Wait, did you get for the chi-squared, did you get 9.63?
No, I got 4.013.
Yeah, you got to have the A and the B. So you might want to get a new tab. And it's good for me to know, and I'll see if I'll figure out a way to adjust it so you can actually put it into the.
I think I know what you're supposed to do. You're supposed to just like pretend B wasn't there on your screen. It pretty much just looks like as if there's only, yeah, it looks like that.
Right. And
So
if I hit a tab.
Then it just pretty much wants me to do each.
Every other?
Like 47, 65, 35, 59.
I think so.
Yeah.
Yeah, I think it has to do with it got squished.
Yeah, okay.
Yeah, and I'll see between now and Tuesday whether I can fix that. That's a really hard one. It's hard to deal with the changing the screen size. It's an issue of changing the screen size. I'll see what I can do about that.
Okay.
But
Yeah,
I can't fix that while we talk. That's going to be a big coding thing.
4.0125 is what you got?
Yes.
Okay, cool.
Yeah, so that's in every other, right?
Yeah. That's just like for like 47, 65, 35, 59. You see? It's just like pairing each one.
Yeah, I'll see if I can fix that between now and Thursday to make it work on a smartphone or on a small piece.
Okay. If not, I mean, it's not that hard to.
Yeah, but remember, it's not just the two of you in the class.
Yeah, right. All right. Well, now that we have our p-value, we can conclude.
So do you want to state the conclusion?
Yeah, it would just be there's statistically insignificant evidence to conclude whether whether men and women have the same ordering or whatever. Something like that.
Yeah, something like that. I agree.
And the idea is you should always copy and paste your H1 after the word whether. Does that make sense? So whether the distributions, right?
So we did it right?
Yeah, looks good. Any questions?
I think we're good.
What I have found is that this is, chapter 11 is probably the easiest. The easiest chapter that we spent a whole week on. One of the reasons why we still spend a whole week on it is, what is your big focus this week anyway?
The project.
The project. So I try to lighten up this week, okay? And chapter 10 wasn't that hard either, but you had your exam. So last week and this week were hard weeks, not because of the new material, but because of the exam and the project, okay? Whereas next week's a bit harder, just to let you know. We still have more to do today, by the way. And it's much more important. Next week is something, it's probably the most used piece of statistics there is. Okay, and that's regression analysis. So just let you know that we do spend all next week on one chapter, but it's a little deeper and it's much more used. Whereas chapter 11, you only see in research articles. Okay, have you ever seen a chi-squared in general? Had you ever seen a chi-squared before?
No.
Right, probably not, right?
No.
Okay, but if I said, have you ever seen a histogram before this class, I bet you'd say yes, right?
Yeah.
Yeah, so there's some things that you see just in general use and some things you don't. If I said, have you ever seen a confidence interval? You would have probably say no, even though you just didn't know that's what you were seeing. Because a lot of times you'll see a report and they'll give you an average and they'll give you a margin of error. That's typical, but it's usually at the bottom of the article, which most people don't read. Just let you know that. So just to know, and hypothesis tests you see all the time. You don't see the word hypothesis test. What you see is the title of the article. The title of the article says something like, more people are concerned about social distancing for, general businesses than they are for protests.
I have a
That's a
question.
hypothesis test. I don't know if you realize that.
I was just curious, do you ever have us interpret the p-value for a homogeneity test?
I usually don't, because it's a little complicated.
Okay.
Because there's a number that you get, the chi-squared number, but what it means is a little too hard for you to understand in this class. So I don't, because it's too hard. Does that sound okay?
Sounds great.
So don't get mad at me because I'm not teaching everything, but I really think it's too hard. On the other hand, I don't think it's, it is hard to do it with, in terms of the p-value for one sample or two sample hypothesis test with quantitative data, but you can do it. And it's something I can explain it to you and hope you might get it. Whereas I think this would be completely hopeless to explain because there's a lot of math. There's an intense amount of mathematics that happen behind the scenes. But the idea is you don't have to worry about it, and you never will, because that's for mathematicians to do and computer programmers. The users, the psychologists and the nurses, or the nurse researchers, whatever, they don't have to do the math. They just have to use the answer. But the p-value, so the p-value is too hard to understand of what it is a probability of. Okay, if that makes sense. Okay, so now let me move on. Let me scroll up to our next topic and our last topic of the chapter 11. And that is test for independence. Okay, it's weird. It turns out that test for independence looks a lot different than test for homogeneity and test for homogeneity. But it turns out, which you'll never learn why, it turns out mathematically, they're the same. But you're not going to see the math anyway, so it doesn't matter to you. But just let you know that the mathematics behind independence and homogeneity are exactly the same. Whereas goodness of fit they're actually pretty similar, but not exactly the same. So independence, test for independence, is all about instead of two groups or two populations that you're comparing their answers to, now you're comparing two answers from one group. And you want to find out, are they independent? Or are they dependent of each other? So if you know the answer to one question, does that tell you anything about the answer to another question? Is that clear? So let me write that out. Test for independence is the following. Okay, if you want to see if two answers or two questions answers are independent of each other or dependent, then you use a test for independence. Okay, in other words, oops, I have two R's. Google's really good about finding my mistakes. I think that one's right though. In other words, if you know a person's, it doesn't have to be a person, by the way, but just makes it easy to think about, answer to the first question, does that change the distribution of answers to the second? Okay, or the probability of each one is another way of saying the same thing. Where have you seen independence before in this class? See if you remember. Where have you seen it?
In the last chapter.
A little bit in the last chapter, but not for this type. Okay, probability is where you've seen it when it comes to qualitative stuff. So do you remember you had to decide whether two things were independent or not? And do you remember there was a probability of A and B equals the probability of A times the probability of B? Do you remember that happened? I mean, it was a while ago, a month and a half ago or so. So it was a long time ago. It was in April. But we talked about it. And it turns out what this is a compilation of all of checking to see if all the individual things are independent or not. And this is a compilation of that. Any questions on the idea? Any questions? Okay, now let's take a look at an example.
I'm sorry, could you scroll back just for a minute? Because I was getting that last, I was writing down that last
Sure.
sentence. Thank you.
The good thing is that if you have a question or a suggestion or a request, you know that at least 50% of the students here care about it. Sometimes 100%, never 75%.
I'm finished, thank you.
Okay, and you're good, Eris?
Yeah.
Okay, so here's the question I've got for you. Is there a relationship between the type of town that a college student grew up in and the club the student is most active in? The results of a study are shown below. And by the way, I made this up. There wasn't really a study, but you can imagine there could be a study. This is definitely a survey you could do. Okay, run the full hypothesis test. And what we've got here is we've got someone could have grown up in the city, someone could have grown up in the suburb, or someone could have grown up in a rural area. Does that make sense? And in terms of the club, they could be in an academic club, like maybe the math club. They could be in an athletic or arts club. That might be in football club, something like that. They could be in a philanthropic club. Okay, that might be like Kiwanis or something, I don't know, some kind of philanthropic club. Or they could be in no club. And what I've got for you is the results of a survey. And we have seen these tables before in chapter 3. Okay, but again, chapter 3 was a long time ago, right? So what does it mean, say, for example, this 60? What does that 60 mean for this table?
Suburb and philanthropic.
Yeah, so in particular, it means from the survey, 60 people are from the suburbs and enter a philanthropic club. Does that make sense? Okay, so what you're going to do is you can do the survey. You're going to ask the person 2 questions. You're going to ask where they grew up in and what club they're in. And if they said, I'm from the suburbs and I'm in a philanthropic club, then you're going to put a check mark in this dash mark right here, in this cell right here. Okay, and you're going to ask every person that and put check marks and you count the check marks. And these numbers tell you the counts. Any questions at all about these tables? Now, here's the hard one for you. And maybe I'll get lucky, but I doubt it, but we'll see. Do you remember what you call this kind of table? There was a word for it. We talked about it in chapter 3.
Contingency?
Nice, nice. You got an amazing memory. Yeah, it's called a contingency table. Okay, so it's a contingency table. And it's exactly the same as chapter 3. The difference is in chapter 3, I said something like, are being in the suburbs and philanthropic, are those independent? Do you remember doing those questions? And then you had to do a calculation to find out if they were or not by looking at the probability of suburb, probability of philanthropic, multiplying those together and seeing if that's the same as 60 over the total sample size. Okay, what a chi-squared test for independence is going to do is say, well, none of these are going to be perfectly independent because this is a sample. So the question is, how far off from being independent is it? And if it's very far off from being independent, then there's going to be a measurement of how far off that is. And that measurement, as you might guess, any guess? Is called, when I say, you'll say, of course. Should I tell you? It's called chi-squared. Okay, the chi-squared is the measurement of how far off it is from being independent. Okay, just like when you did distributions, the chi-squared is a measurement of how far off it is from having the same distribution. Okay, if chi-squared is 0, then it's perfect. Okay, if chi-squared is, say, 1.1, then it's not that far off. If chi-squared is 43, it's really far off. Okay, and again, you're not responsible for getting an idea of how much you need to be really far off. Because every degrees of freedom matters also. Whereas if you're talking about z-score, that you are responsible for. If I told you the z-score was 7.4, what can you tell me? Is it very far off? Is it not very far off? What do you think if a z-score was 7.4? Yeah, that would be extremely far off, because even 3 is extremely far off. So 7.4 would be amazingly far off. Okay, so chi-squared has something like that. It's kind of the same idea. Any questions on that idea? Okay, so now let's go ahead and work out this problem. The first thing is the test. It is called chi-squared test for independence. It's not good enough to just say chi-squared test, because all 3 of them are chi-squared tests. So the word independence is the key word here. Okay, any questions on that? Okay, what do you think the next thing we would do in running a hypothesis test?
H0, H1.
Yeah, exactly. So let's go H0. Okay, and I don't expect you to be able to do this yet, but I do expect you to do it after 5 minutes from now, because then I'll show you how you're supposed to do it. Okay, so the first thing is, just like in tests for homogeneity and goodness fit test, there's a keyword. Here, the keyword for H0 and H1 are different. The keyword for H0 shouldn't be too much of a surprise. It's independent. Okay, so what we're going to say is the type of town that a student, a college student, grew up in, and the club that the student is most active in are independent. Any questions on this H0? Any questions on this? Okay. The good thing, just like with the other tests, is I can copy and paste. I love copying and pasting. Okay, I hope you all know I need to change that 0 to a 1. That shouldn't be anything new. Here's a hint. I need to get rid of 2 letters.
In.
In, exactly. Exactly. So H1 is the type of town that a college student grew up in, and the club that the student is most active in are dependent. The word dependent is the opposite of the word independent. Any questions on H0 and H1? Okay. Is that clear so far? All right. Just a note, and that is kind of important, that a lot of times you're interested in this for a reason that we talked about, and I know you probably hate when I say these kind of things, in chapter 1. What if we talk about something like this? Open this up. I know it's been a long time.
Given.
Okay. Yeah, remember?
I mean, it has to do with given.
Now it's chapter 3.
Wait, what's the question?
Chapter 1. How does this relate to chapter 1?
Oh,
Why would you need to do a chi-squared test to get started in chapter 1?
I don't even
In
remember.
a piece of it. Okay, so let me give you a hint. Stratified sampling.
Mm,
Should I tell you? I know it's been a long time. Because if things are independent, then you don't need to stratify by them. If things are dependent, then you could have bias. So if you only ask people in the city, so if you go to downtown San Francisco and you do a big survey asking them what club they're in, well, if the type of residence they're in and what type of club they're in are independent, then that's fine, there's no bias. Do you see that? On the other hand, if they're dependent, then that would be biased to only ask city people. Does that make some sense? So if they're independent, if they're dependent, then the type of place they grew up in would be something you'd want to stratify by. Whereas if they're independent, there's no reason to stratify by that. So we never talked about why you choose, or we never got into the details of why you choose what to stratify by. But this is the reason, is that if they're dependent, you have bias based on not stratifying. If they're independent, there's no bias if you don't stratify based on where they live, for example. Any questions? Did I lose you that, or does that make sense?
sort of.
So if their answer to the question has nothing to do with whether they're from the city, the suburb, or rural, then it doesn't matter if you only ask city people. Does that make sense?
Okay, yeah.
But if it does have something to do with whether the city, suburb, or rural, then it does matter, and you better stratify by it,
I see.
or you have bias. Do you see? You better make sure you don't bias by one type. Okay, and this is one example. It's not just it's not just city, suburb, or rural, but this is ethnicity. We talked about that. Stratifying by gender, stratifying by whatever you want to stratify by. Usually, the first thing you do is you do a small test, and you do a little test for independence, and that tells you what you might want to stratify by.
Okay. So like if the question was like, let's say about breakfast selections, then it'd be fine to ask all city, is what you're saying? Just stratify by something else?
So if you end up saying that, if you end up saying that they're independent, then don't bother stratifying by that.
Mm-hmm.
If you find out that they're dependent, then you better stratify.
Okay.
That make sense? So that's one of the main purposes of test for independence. But sometimes you get lost in that. You learn how to do it, but if you don't know why you care, then what's the point? Does that make sense? If this was useless for everything, this wouldn't be taught. But this is really useful, and that's what it's most useful for. Okay, the other thing it might be useful for is, and this is especially important now, is you might want to say, well, is there a racial bias in major, for example? Okay, so what you could do is you could do a test for independence on race versus and major. And if you find out they're independent, then there's definitely no bias. Then it doesn't matter what race you're in, what race you are. If they're independent, then race has nothing to do with it. Does that make sense? On the other hand, if they're dependent, then there's bias. And then you might want to say, well, there's bias, and then you're going to look further, which we're not going to do in this class because it's elementary stats. But you know, in more advanced stats, then you would look further and say, all right, what are the issues? Okay, who's being discriminated against? Which race is being discriminated against and how? You know, does that make sense? So maybe it's STEM majors, and maybe STEM majors is the problem that you don't have a good racial distribution, or maybe it is the not STEM majors, maybe it's humanity majors, or maybe whatever major it might be. Does that make sense? So that's another reason why you might care. So I figured again, otherwise you're just like learning how to do something with no reason to do it. But there's actually big reasons to do these tests for independence. And those are the two main ones. One is to decide what to stratify by, and the other is to see if there's bias. Those are the two main ones. Or another way of, instead of bias, you can also look as if you're a business person, if you say, well, it's independent, then you could have more of a broad advertisement. If they're dependent, then you want to advertise a focused group and put all your effort there because that's where you're making your money. So that's another reason why you'd care about this. Any questions on that? Okay, so now you need to find, as you're used to, what do you think's next? What do you have to do next for this problem?
Now you're going to go and use the calculator.
Yeah. So we need to find the test statistic, and we need to find the p-value.
I got that.
So, and the good news is, if I did my job right, and you can tell me if I didn't, and I'll fix it. You tell me which one, what number you need to go to.
Number 21, the test
Yeah.
for.
Then I did my job right. I tried to make it obvious, okay? But only if you know the name of the test. If you don't know the name of the test, you can have no idea what calculator button to hit. So knowing the name of the test is absolutely essential. So I'm going to go test for independence. And then I want to see something. Let's see if it's going to cause problems. I have a feeling it is. Ah, no, it worked okay. Okay. So if you have a smartphone, for example, you're doing on a narrow screen, it's going to look like this. If you have a wide screen, it's going to look like that. You have first, second, third, fourth. Okay. And it turns out, actually, it doesn't matter how you column. In other words, which are rows and which are columns. For independence, it's symmetric, so it doesn't matter. If you make that mistake, it means nothing. So this one worked. So let's see if I can make the other one work too. Okay, so now we need to put our numbers in. And they were 82, 51, 71. There's always busy work. Sorry, 42, sorry, 71, 43. What I haven't figured out how to do yet in the program is how to read your mind. So it'll just like know what you're thinking and put the numbers in. You have to type them. If you could tell me how to do that, let me know. You'll be famous. 67, 54, 60, 52. I think, whoops, I didn't hit tab. Do you think computers will ever be able to read your mind?
Yeah.
I think so, but I think we'll be dead. I think
Truthfully, I think they probably already can. It's just not widespread. I think there's a whole lot that can already be done that we don't know about.
No, it can't read your mind. I'm a programmer. It can't.
Oh.
No, I'll tell you when it's going to happen.
Okay.
When you have a chip in your brain.
Okay, yeah, I guess that.
Not if, when. It's going to happen. So 40. But we don't have chips in our brains, so it's not going to be able to do that. Okay, so any questions on typing in the numbers? And again, in fact, this would be kind of cool. Notice that if it's a smaller screen, it's going to look like this. A bigger screen looks like this. Now I'm going to hit calculate. And what do you think? So what do you think based on what we've got here?
Well, the p-value is pretty high, so I'm going to definitely say that we're going to fail to reject.
Good, good. We got a p-value of 0.347. That's bigger than any level of significance we're going to ever use. So we fail to reject. Okay, so let's go back. And we can say that the chi-squared was 6.72. And just to note, this is very different than the z or the t. The z of 6.72, that's a reject. Chi-squareds are different, so you can't use your, like, you know, just feeling of the number. That's not going to work. So you have to look at the p-value. P-value is 0.347. Any questions at all on getting the chi-squared and the p-value? Okay. Now that we have that, let me make it all on one page. There we go. Now we're ready to state our conclusion. First few words you better all know.
There is statistically.
There is, good. Okay. If you don't have that by now, I have not done my job. I'm trying to drill it into you. There is statistically. And now, is it significant or is it insignificant?
It is insignificant.
Yeah, insignificant. Evidence. To conclude that. And the good news is, copy and paste. Some of my favorite words in the world. Oops. That the type of town that a college student grew up in and the club that the student is most active in are independent. So we don't know if they're independent. We don't know if they're dependent. So often what you do is you look at the p-value. P-value of 0.347, usually that means your sample size is too small. It means you need a bigger sample size. And because the p-value of like 0.9, that means you give up because they're probably independent. You can't say it, but you're trying to give up. A p-value of less than 0.05, that means you got it, right? P-value of 0.347, who knows? Okay, so that's just a note. Okay, any questions at all on this example? All right, I just want to mention something. I kind of said it, but I didn't get into it just a moment ago, and that is sample size. So what do you want for the sample size for this to work? Okay, hopefully you know that if you ask 3 people, that wouldn't be enough, right? Especially if there's, 4 different categories they can answer for the second question. Then obviously asking 3 isn't enough. So how do you have an idea of how many people you need to ask? Any ideas? Okay, it turns out that you want to make sure that all the, I'm going to say expected counts, but for our class, we'll just go for what you see. All the counts, and there's a formula called the expected counts, must be bigger than 5. Okay, if they're not all bigger than 5, then your sample size is too small. Some people go by bigger than 10, but more go by bigger than 5. And just a note, same is true over here, is you got to make sure everyone's bigger than 5. Does that make sense? Okay, and same was true for goodness of fit. All the expecteds have to be bigger than 5. If they're not all bigger than 5, then you shouldn't even do this test. What should you do if they're not bigger than 5? Right? If you were conducting a study on any of these guys, the one we just did, for example, and you don't have bigger than 5 for your counts, any thoughts? Don't see jumping in. You should survey more people. Okay, means your sample size is too small. So if you're not bigger than 5, guess what? You need a bigger sample size. You need to ask more people. Okay, go ask a bunch more college students and find out what they say until you get a big enough numbers. Okay, don't even think about running statistics with small data sets. Okay, is that clear? And this is qualitative, and qualitative is bigger than 5. What was quantitative bigger than? Remember? What number was the key number? 30. Yeah, so qualitative has to be bigger than, quantitative has to be bigger than 30. Qualitative, all the expected counts have to be bigger than 5. And it wasn't the number you survey, but these values. In this case, it's all these expected values. In a fancy calculator, you can get the expected values, but I think I'm not going to go over that. The math is a little messy. It's doable, but it's messy. Any questions at all on these ideas? What do you think the hardest part is if I give you a problem like this on the final? Especially if I give you a problem like this guy in the final. Okay, or the other one. What do you think most students have most trouble with? Yeah, exactly. Well, what you're thinking is right. Deciding what, not tie-east, but test. That's what you meant. So deciding what test you need to use is definitely the hardest part and the first step. Okay, and I will let you know on every test, every final exam I've ever given, and I've been teaching for a quarter century now. The first question is all you have to do is state the test, and you don't go any further. And there's a bunch of parts, and each one you have to decide which test to use, because that's actually number one. If you can't do that, then I've wasted my time. It meant you didn't really get anything out of this class. You have to know which test to use, because, for example, a year from now, when you're doing upper division work in your coursework, or maybe 2 years from now, wherever you're going to be, if you know which test to use, you're probably going to forget the details a couple years from now. But you're going to be able to go online and type in the name of that test and get a couple paragraphs and be able to just do it, because then it'll review. If you don't know what test to use, you're screwed. That means you have to reread all of the statistics that you have in a stats class and start from scratch. So knowing what test to use is the most important thing that you need to be able to do to really use this stuff. So let me mention, or see if you guys can jump in. If it is a test, a goodness of fit test, what draws that one apart from all other tests? What are the few things that it handles? So what does the goodness of fit test handle? You can type in or say it. Because I want to go over each of the tests, but see if you remember. I know it's been 2 days. Actually, it's been 2 days because you had a quiz on it. And if you're comparing one unknown to, yeah, you're comparing one unknown. I want to put a keyword, one unknown distribution to a known distribution. And I want to specifically say distribution because a regular t-test for a proportion or a t-test for a population mean, z-test for a proportion or t-test for a population mean, those also compare one unknown to a known. Do you remember that? But those compare either a one known proportion to a known or a one unknown mean to a known mean. Whereas a goodness of fit compares one unknown distribution to a known distribution. Is that clear? Any questions on that? Okay, what about test for homogeneity? Kind of in a few words, what does that do?
It compares two distributions that were recently done.
What does done mean?
Means like previously it was a known and an unknown. These are both brand new basically.
Yeah, unknown. So they're both unknown.
Yeah.
Yeah, so it compares two unknown distributions to see if they're the same. Okay, or not. So it's two unknown distributions. So in particular, you're going to have two populations, and you're going to do a sample from each of the populations to see if the distributions are the same. Any questions on that? Okay, then the final one is test for independence. What does that do? Yeah, so now we have two qualitative variables, and all these are qualitative, by the way, for this whole chapter. Two qualitative variables, and you want to find out if those two variables are independent or dependent. I'm going to give you some other words that you'll see sometimes, and associated is another. So you want to say, are they associated? Another is related. Is there a relationship between the two? And then the final one you'll see is one a factor of the other. So that's just language. They all mean the same thing. They all mean independent or dependent. Okay, so if one's a factor, they're dependent. If one's not a factor of the other, then they're not. Then they are independent. Any questions? Any questions on chapter 11 at all? Any questions? Okay, I think I'm gonna call it because we're about done with time. I always try and make it around the right amount of time. And hopefully made sense. And you could always ask questions if you have them later too, because don't forget, the big thing is happening in a few weeks. Okay. I was hoping to have you guys answer. Are you reading the chat box? I'm going to stop the share and I'm going to stop the recording so that you can say it without being public.